Okay, guys. Frankly, I was hoping one of the other engineers would be smart enough to see this, and I've been waiting. I know they watch my content, but apparently they just got a copy and they don't have coconut for it. So let me just go ahead and stop playing around and give you some more data. Let's data stack you. I gave the question up numerous times saying, how do we get across there? I gave this section. You know me, I do my smoke and mirrors. Look in this left hand. In reality, I'm doing something with my right hand. But with that said, I'm trying to draw your attention to what the other hand is doing. But I give hints. You know I give clues. You know I do the just like Columbo when he talked to you. You always were missing the damn question that he was really after. All right. So here's our drop. This is still questionable. This crack fracture in the middle. We now understand this. Let's give the credit out to Tom. Tom sees the C as everyone else sees it as something else. Tom sees the C in the gate and compression pulls it in to approximately here. That gives us what, Tom? If we see the C over here, Tom, and the C is really center line of the gate, that gives her angle of view. Because it doesn't compress and move it over, it just brings it forward. So it will show your angle of view rather. So her angle of view was more going this way. I know our pool presents is over here, but apparently when she started the video, I think C is somewhere about here maybe. So angle of view, we would put the C here, we put the gate center line here. Now we start getting her angle of view based on that C. We do see some significant amount of concrete on this side. Oh, that's running into my bias now. My bias construction joint onto the upper deck. I'll show you that in a minute. But what I want to show you is that I gave the clue many times. I said, how did they do this? Is it solid poured? Is it solid poured? Well, apparently all the brilliant engineers out there watching me jack off, and not an engineer, and Josh, and you can even add Greg, whatever his name is. All of them can't figure out what they're watching when they watch my own damn videos. It's a shame. It's disgusting. You guys need to just leave it alone. Move on. Move on to whatever you do before this came about. Go back to doing that. This is not your skill set. Let's jump over here now. Clearly, what does this say? 5 number 12s turned at an angle. This is on the BMA. This clearly says a 7-inch drop. This clearly says 5 number 12s connecting on the BMA this way. This clearly says 5 number 12s connecting on the BMA this way, and I'll explain that in a minute. This is an elevation change, 1 foot 11 inches, 1 foot 11 inches. So 1 foot 11 here, remember this is working from the 1110 to 1010 drawings. 1110 to 1010 drawings, so this will be changed just a little bit. But nevertheless, when you get the rebar here is not going across. This is an elevation change, and this is how they wanted it to be reinforced. So there's a void or an elevation change in the deck here. If you go look at the images from the parking garage, you will see an elevation change here. This small elevation change. You will see it step into the ceiling. Okay, we'll get to that one in another video unless somebody beats me to it, right? But we've got the same deal going on here. It goes up to the line and stop. Flower pots. We'll talk about that. But let me show you now how this matters. This shows you that we can have the deck failing and stopping here, ripping out from the top of the BMA. We have data to prove that under this, what you guys call an I think an HBMA or H-beam, whatever you guys call it, different names. I like the name of it. It looks like a shape of an H, so why not call it an H? It'll help orient us to where we're located. Everyone knows what, at least on my channel, knows what they're talking about when someone says H. Now there's another H down here too, but we don't consider that one an H, right? This is the one that was intact. Or is it intact? Is it intact? I ask that. Or does it look like a U? So coming over to the beautiful model, here's our construction joint, and it would go up to there. And that would relate to the construction joint I just showed you behind me. which is this one. That's the top deck. That's where I also mentioned that you can see in the video, you see part of the deck down. Now, is it over this far, or is it, you know, just a little bit more? I can't be sure of that. I would need to know the scale of that distance. With compression also makes things smaller. So that puts us up here. If you follow this construction joint right where this marker is. And that puts us pretty close to where that corner beam is. Now 14 by 18, I talked about this. That's 252 inches. These are 16 by 16s. That's 256 inches. They're about the same. So we're not going to cry over looking for 4 inches unless you happen to be a woman. All right. So now down here is where we get our reinforcement. There's a flower pot. Our reinforcement in this raised, where's my little cardboard? This raised deck. You come out of there. Oops. Part of it got taped in there. Sorry about the lighting. Yep. So part of our reinforcement on the BMA is that raised deck and then a lower deck behind it. But we see the reinforcement is 5 number 12s. That's what I'm pointing out here. 5 number 12s. And then here. So as we get this deck failing out here, we can get our crazy torque action going on. We have multiple elevations. So as it's pulling up on a ramp, if you will. It's pulling up on an elevated deck. Pulling from here, pulling up on an elevated deck, changes the moment of its reaction where it's pulling. And remember, this is not 2'6", this is now 1'6". So now we're getting closer to pulling at the top there. And remember, when we pull at the top, we start this bad boy shaking, rattling. We don't get to pull it. We don't get to pull this. We don't get to pull it. Pull it for free. We start changing the... See that little bit of movement? That little bit of movement is all we need. And all I did was just pull this just a little bit. Let's see if I can do that for you. I know it's configured wrong. But you see, the cardboard's just barely moving. Yet we're getting a frequency way up top. So now, you see where you can get your connections now in this deck. This deck here is connected to here. I'll walk us over now. I'm slowly creeping you up to. I don't want to give you. I have to do it in steps. If I try to give it all to you at once, slam you, you're gonna drive yourself crazy. Don't want to do that. Here's that rebar you see in another video. This is basically why it just separates. On the underside of this, though, for being fair, the underside of this, it does have some rebar, but it's at the bottom of the concrete. So here's the concrete, and this is at the bottom, barely enough to hold on. It presents as that when we see it on a slope back into the upper deck. So there will be upper deck, probably a little more bend than that. Probably like this piece better. It presents like, maybe I like that better. It presents more like that, slope down on the underside. You see it connected to the underside of this deck into here. Down here we barely see it at all, but it's there. It's on the very underside, the very bottom of it. But it was supposed to be three sections, as I showed you in the previous video. It's supposed to have been configured with three pieces of rebar. So the joint, 1, 2, 3. But that's how it was supposed to be configured, and the thirds. So that's how it was supposed to be configured. In reality, it looks like we get this. We get a say that's that same slab. It looks like we get it somewhere about here with very little cover. So minus cover. All right. You get very little cover of one piece instead of a joint. It looks like that. So profile wise, remember profile? How I'm sorry, I should have done this. Oops. So rebar would have gone through 1, 2, and 3. Instead we get we get somewhere about there, maybe an inch of cover. We get a 1 off, and not this, and not that. So now we don't get the slowing down. So we have a BMH over here. That's not the BMH, a BMA. That's not present. That's not present. And then we could have also had a saving of the collapse if we would have stopped it from going that direction. And perhaps this reinforcement in this control joint would have stopped it. It would have come this way instead of shearing off and going that way. It would have meant that extra rebar reinforcement and would have went down in this capacity, pulling over to the pool, possibly shearing there, but it would have been jointed all the way down like this, all the way down. That would have slowed up any of that braking coming across. So now we have another means that could have saved this collapse progressively going back to the building. That would have been if this construction joint was done properly. So then we get the puncturing over here. It comes here, just breaks free, and just rolls over towards the building. We get to the BMA there. It rips out, as we can see in other situations. It rips out, but it tugs on the structure. Takes a fall down. It's too late. It's tugged on it. It's caused this racking to take place in the main structure. That tug is not for free. We get an internal slab drop. Now, let's go back to this darn refrigerator stuff. Come on, guys. Look, we got 20 foot of slab drop. All right, unless you got another break inside here for some reason, and it's possible that they did this slab drop as a joint. Watch it. So it's possible, because I don't know what it looks like. It's possible that it looks like, if I'm looking at it from the top, and this would be this could be a joint here. You know, they could have rebarred in here, coming out of this. So let me make it long. So let's do that one kind of long too. This would be the top view of this. So it's possible they could have done that. Okay? So it's possible that is what we're looking at here. So there will be rebar in here, right? So rebar, and then rebar here tying into this slab. If that's the case, so if I put lines in there, which I don't want to do right now, we can get a tug. It separates from this rebar here, from this slab here, and it drops this section down. Boom. That makes this now unstable. And we get 7 minutes of creep, of accelerated creep, I call it. It means you've got a force in there that's going to end in failure in about approximately 7 minutes. Now, please go to the video for people. I know I piss off a lot of engineers with accelerated creep because there is no term called accelerated creep. I call this accelerated creep. Creep will result in failure, right? So this is accelerated creep. It's a 7-minute timeline. So if you go to the video to prove it, you go to the content that I posted on. You go to the content that I posted called Parking Garage Partially Collapsed Near Irvine Medical Center. You can watch accelerated creep. This is over it takes the helicopters viewing this in over 7 minutes time. Over 7 minutes time, we see this go down. Look at that. But the helicopter is recording it. And I'm going the other way. Hold on. So I'm putting it backwards. So you watch the helicopter flies over. The medics are down. The firemen are down there. And they don't know it, but just in a matter of approximately 7 minutes flying time, this ledger will roll over on them. So let's see if I can get you a... It's right behind this banner. This ledger falls down. And now imagine a structure, the columns on that, and you get the same failure. Let's go back. I think they have a better image without this banner on it. Let's get rid of the banner. Okay, so I'm going back 5 seconds at a time. Okay. So now we have go forward. Let me make sure this is the car in the garage. Okay, here we go. Take their time, dilly-dally around. Let me back up. So let me pause that audio too. They're going to climb up. So you see the firemen are right there. They think this is stable. They believe that this section of the deck is stable. They're right there in the path of it. Because they see it as, oh, it's not moving, so it's stable. And that's that an item at rest bullshit that people hear. Well, everything's secretly equilibrium. It's not at rest. This has still got strains on it, and it's still trying to find equilibrium. Now, let's scrub it and scrub it, right? So let me scrub this forward. So there we go. That's the collapse. I did it kind of backwards for you guys so you could see it. And right about there. Let's let it play. Okay, so let me go. I'm trying to find that rollover. I want you to see the rollover of the ledger here. And once you see the rollover of the ledger, you'll understand the rollover of that slab of the rollover that could have taken place. All right, that's going to be the rollover right here where my mouse is, up here. That's going to be the rollover. The white cars are coming down. Let's go fast. 5 seconds. That's another view. And now we'll record. Now let it roll. Because the helicopter's in the air filming. You know, she's just talking about the scenes down below. Not knowing that this is next. This is my accelerated creep process I'm talking about. It just has not found equilibrium. And so we got 7 minutes timeline before the collapse. Let's fast forward. Now they're rolling around. The helicopter's still showing it. It looks like it's in plane. It looks straight, doesn't it? But there's a torque action going on here. There is a torque force inside here. There is a leaning torque force inside this structure out here. It is not plumb and square. It presents as plumb and square. But those forces are there. And they're going to present themselves to the public in just a moment as I let this play on. Just bear with it. That's my narration. Again, you guys can go find the video under under the other title. Let me pause it under my title right here because I do the narration. Champlain Towers Collapse, concrete parking deck. Come on, baby. Failure. Anyway, I'll link it. Let's get back to it. Now, still narrating. Oh, at this point, I think I did it backwards, trying to say, look, I want you guys to try to guess what happened here. And then I put it backwards. So let me go forward a little bit. Well, I'll just use a scrubber. So put it back up. And there it is. That's going to be the best image right about here. Now watch this rotate right here. Watch this rotate up as it plays. See it flip back up? All it did was take a rotation. It's still in the air. It just rotated from its joints. Imagine if they had those joints connected across. That would have helped it, stopped it from rotating. It would have sent it down here so it'd make it more tight, like a tie beam, but that didn't work out that way, did it? So now it's going back into place. It only took a little bit of rotation is what I'm proving here, showing you. Just a little bit for it to fall off, because this is still there. Look, this is already fallen. And it's not much of a rotation for it to slip off. It's still not in place. It's just about still in motion. So look how much rotation it took. Just a touch, a tap on the shoulder for it to rotate and roll that down. But the forces were there. They were present. What I call accelerated creep. It has not found equilibrium where it's stable. So let me fast forward now. The helicopter's rolling around. There are those guys. They just got lucky as hell, right? They would have been knocked down like bowling pins. Okay. Let's go forward. And right there. Now in this video, I try to show you that, I guess a lot of you guys missed it. Well, it's got 8,200 views. A lot of you guys missed it then. Boom. Right there. It's already got the shear plane. You see the shear plane happening, ripping between the two decks. Actually, this is a different product. I got some of my edit got cut short. I was going to show you more of it in real life that I had on a job site. Then I extrapolate trying to show you that what took place. So we don't need much for it to tug on to get that to drop down inside. Just like that beam. Just like you saw in the beam, the fireman out here. It drops. Bloom. It's not for free. It wants to pull on this now. It does pull on it. And then we get that 7-minute delay time. I'm showing you that 7 minutes can happen where you have a stress there and nothing. But possibly, this is only 1'6", possibly it tore out more of this than we think, but more so under, possibly, maybe equally even under both of these, under M and N. I doubt it because the reinforcement's different at that location on each one of these columns. I'll show that in future videos. I already gave a hint of that in another video where I went over that corner, where I played around going, look over here. You know how I do it. And then I'm like, oh, look over here. Oh, these are different. And that's what I'm driving you to, that these are differently reinforced. This column location and even that column location differently reinforced than that column over there. The tributary areas are greater between here than here, only by like 1 foot. This is greater distance. But yet our reinforcement is very different around the tributary areas. And specifically, we appear to have a construction joint. So we get a tugging here, we get a rotation there, we get a dropping of the deck, maybe a flipping out of some of this. Back to what I said I'd get to. Look, guys, I just don't have those furniture coming down like that. Maybe only half their property fell down. Their deck maybe just dropped and elastically bounced some of their furniture off. But if we get furniture dropping, I mean, they had some furniture in their room, in the house, right? Don't we get a bunch of furniture? You know, don't we get furniture sliding down? Or at least stacked up like that? Don't we get this? Is this not, should this not be part of the view? You know, on an angle, but it presents as she films on an angle a little bit down, just a little bit. She's just a little bit, maybe down like that, and on an angle like this, we see, because here's the sea over here, and then right about here is that other column, and concrete's beyond that column. We see this thing. Now, my man just sent me an image. It's interesting. It looks like well, it's a ghost, because I start seeing the same thing he saw. So I don't want to go down that track yet, but the furniture, right? Where is it? It elastically could have bounced off, you know? It could have bounced off. It's a 13-foot drop. It could have, you know, bounced off away, you know? It's not, you know, but all of it, that I find that amazing, unless I just come forward. Now, I don't have it as the kitchen. That's a huge amount of kitchen up here. I'm sorry, kitchen is there. That's a huge amount of kitchen. But the kitchen is over here, I believe. This is the living room. I believe the kitchen goes up to the hallway. The hallway's right about there, so this is kitchen space. So that's why I have the kitchen space there. But if you're going to have the kitchen, when I looked at the diagram, I would put right here, looking at C's apartment, I'll probably put a washing machine on this side right here. Bring it back to that damn washing machine. And possibly when that fell down, the washing machine fell over on top of it. If you want to go back to the washing machine, it's definitely not detailed enough to figure out what it is. It's not a flower box. It's not a flower box, right? Flower boxes are up here, and that's way up there, and we have it closer up here. So compression brings things forward. If that's the case, then all this is fake, and it's back here, and this came forward, and none of this fell. It's just this, and I don't have that because I'm going to show you in my model the elevation changes here. I'm going to add elevation flower boxes like this. We're going to get more and more detail. I'm stepping it up for you guys to get you there. So before we end the video, let's put our toys back. Remember we had an elevation change, which is really up here. So remember we had an elevation change. This was 1110 and this was 1010. That would have been a BMH right here. Here's our flower boxes right there. There's a light pole now that we're adding. We're at this fracture. Thereupon is the alleyway that we created, right? We got the alley going. Now we have the other flower box in the back. I'm starting to stack up that flower box for you. We've got a sausage link, which is part of the columns, and a flower box turned on its side there, about a 45 into the alley. We have baby girl with the baby girls now, that little owl. There's Mama Bear, and there's the son. I need a different version, but they skedaddle out of their apartment before the floor collapses. Obviously, they do that because they didn't report a floor collapse. So we know that that timeline works for us. Okay, we have it's probably not the kitchen, because the kitchen is forward to closer to the wall, to the outside doorway, and we have what people were presenting as a washing machine. Possibly, if she added the washing machine, he or she added the washing machine there, the previous owner. I could not find it in the previous owner photographs. So did she add the washing machine? I was told that she bought it because of a washing machine. I don't know that to be a fact yet. I don't have an image of that. You guys might track it down and show the washing machine in that apartment in the listings, in the real estate listings. That would be great. I could not find that washing machine. Yes, I heard that it should verify. She said she had a washing machine. All right, well, where was it? And then we can just, was it? It would have to basically be here. This is the next room over, so it had to be here. Or the next room over would have to have a washing machine. And the next room over, when that floor falls down, a washing machine could have slipped under and fallen on top of that system here, even if the next room over has one against that wall. But that is the bathroom, I believe, over at the next room over on that outside wall. So could it be a bathtub? And there's the plumbing torn apart? I don't know. That's a rabbit hole you guys can have right now. We'll get to that rabbit hole, but not this moment. So we got curb pressures, we got tires coming in, we got the shear action going on here because we don't have a beam. Okay. Then we got over here that if it didn't have the beam, would this have stopped it? Would this joint have stopped this collapse from going to that building? I would theorize yes, it would have a hell of a lot of deceleration that took place to stop the inertia of the collapse. That it would have to start pulling at all this deck, possibly running it more that way if they had done this joint as such. But they put it down the bottom. That was an easy rip down, and a control joint allowed easy access to go over to here. We get a slight tug. We don't need a major tug. We drop a deck. We start our accelerated creep process because the spans, this is crippled, and possibly this 1'6". Remember, this is 1/6, not 2/6. That's about a 40% reduction in size of beam capacity. Don't worry about the slenderness factor. It already got torn apart when they ripped this, when this got snugged on and pulled on. When it got crippled, when it got bent, when it got deflected. Think of the parking garage video. Go back there and look at that in this video. I'm going to end this video and I'll load it for you. And I'm going to get you there. I'm going to get you there. You got to be patient with me. I just got to give it to you piece by piece. And then we'll talk about even the collapse of the main structure, how we'll pull that apart. But right now we need to get to this main structure, on how it happened, and then we'll get to how the main structure's connecting structure, proof of tugging. And I already did that proof of tugging in a video before. Can you guys find that video? I'll give you a hint. So in this video, which I might retitle, but Champlain Towers Collapse, demolition of second floor will be tough, plus proof of easy rotation. Easy rotation. Let me scrub a little bit here. So right there is the proof of easy rotation. You can see the floors here pretty much collapsed forward, down. But look at the back of these floors on the existing structure. You see all these lines? That was because when it was pulling down, it tugged and pulled on each one of these slabs from here all the way over to here, pulling on them. And those are those fractures you see thereabouts. So there's your hint, and if you want the content to go look at it, you just look up this title right here, under my title here, but of course Google might send you no results because I've already showed Google that I can type in my same exact title and not get my own video. They show me everybody else's channel, but not my same exact. I mean, I made it clear which title I wanted. It's 100% typed in, capitals and all. And so you guys can try and tell me what you find if you try to type in this title. Really? It's so bright, and I can't. Okay, there we go. Okay, that's weird. Actually, bring up the exposure. Helps you see it. So look up Champlain Towers Collapse, demolition of second floor FL. Will be toughest proof. Will be tough. Demolition of second floor will be tough. Plus ease. Plus of ease. Hell, I wrote it and I can't read it. will be tough plus proof of easy rotation. And there's your rotation. So you guys look this content up. Well, 10,900 subscribers. I mean views. That's good. So look this up, and you'll see that's my proof of rotation. You got to look at that. It's going to get good content for you to understand the rotation that's going on, and you could see it. And from here, these floors more. Remember that I said they pulled over, and then I showed you in a video where they just dropped down. At that point, the rotation starts taking place because we start getting rotation tugging. All the way down to there, that son of a bitch tugged. All the way down to there. Either that or it dropped into the structure at that point, and our tugging is in a downward capacity. And we have a slight level rotation of that patio down, and maybe of this one. But these are present as level. And as we see that in the debris field above, and that was part of my pointing out when I pointed this piece of slab here, saying, "Oh, look at that pattern." I wasn't really talking about looking at the pattern. I want you to notice the levelness of the deck beyond it. I also wanted you to notice the hook rebar and the rebar direction, and that tells you where your rotation starts taking place and how consistent it is. And that's all inside here. All that's in there, but we'll get to that in another video. Stay focused. So look at this one, but don't lose focus on this. Don't lose focus on where we're at. Don't. That's not. I don't want you to get left hand, right hand, smoke and mirrors, magician type shit going on. I want you to stay focused on our path first. I want you to start seeing why, the multiple reasons why it failed and went that way, and I also want you to start exploring what would have stopped it, even without the BMA. Would the construction joint have stopped it? I would theorize it would. Okay, terminating video.